Hello, Honors Algebra. Mr. Lawrence here with your flipped lesson. This is the second part of the review. Remember, the test is going to be Thursday. There won't be a review video tomorrow night. You'll have the two parts today, and then we'll get a little review time tomorrow in class. And then you can ask me some questions, get some help on things you aren't sure about. We'll have an answer key, all that good stuff for you. Okay, we need to talk about solving rational equations, and they're going to come in two forms. One that looks like this, which a lot of you will know what to do because you're pretty good at cross multiplying, and two, the other type will look like this, which some of you will get confused on, and so we'll go over it in detail. All right, so on this one, I recommend cross multiplying. I think it's the easiest thing to do. Remember that when you cross multiply, you're going to be foiling, but you're not going to have any fractions. Did you hear that, Mr. Rust? No fractions. The cross multiplication is a shortcut for getting rid of the fractions. So the left-hand side could become the quantity of x plus 1 times the quantity of x plus 2, which will need to be FOILed. And the right-hand side could be x plus 3 as a quantity times the quantity of x plus 4, which will also need to be FOILed. I'll FOIL the left-hand side, and I'll get an x squared plus a 3x plus 2. I combine my outers and inners. 1x and 2x is 3x. The right-hand side will become x squared, and I think I'll get a 7x when I do my outers and inners. And then I'll get a plus 12. Okay, now, it looks like it's a quadratic equation, but it actually isn't. Because when I start to try to get all the x's on one side, or the x squareds, I subtract x squared from both sides, and you can see that the x squareds are going to cancel on both sides. So now that I know it's linear, I'm going to get all my x's to one side of the equation, all my non-x's to the other side. I think I'm going to go ahead and put my x's on the right because I want my coefficient to be positive. So I'll subtract 3x from each side. And then I want my constants on the left, so I'll subtract 12 from each side. And those will cancel. This will become negative 10. That'll equal, looks like a 4x to me. Those cancel. And then to get x alone, I'll have to divide by 4. Oops, looks like we're having a smartboard snafu. And so I will divide by 4 there. And then simplifying that, I'll get x equals negative 5 over 2, or negative 2 and 1/2. And it looks like the computer switched my marker on me again. Oh, maybe not. Negative 2 1/2. Either one of those. Okay. Now, of course, I know that x cannot equal negative 2 and negative 3. I don't really need to state those restrictions. What I do need to do is make sure that this answer doesn't violate the restrictions. In this case, it does not, so I can go with that as my answer, either form of it, negative 5 over 2, negative 2 1/2, or for your fraction wimps out there, negative 2.5, 2 5/10. Okay, but I don't think you're really fractionally wimpy anymore. You're welcome, by the way. All right, now, a problem like this one, I don't want to cross multiply. You could. You could get a common denominator for the 3, you know, h plus 4, but then you're going to have to do h plus 4 in the numerator, and then you're going to have to distribute the negative 3, and then you're going to have to combine like terms, and you could turn it into so it looks just like a problem we just did. I don't want to do that. I think that is too much work. Remember back on the one homework problem, I showed you how to do it that way, and it took like 10 or 12 lines to do it all. The way I'm going to do it now will take a lot less work. I am going to identify the LCD. I know it's going to be the quantity of h plus 4, all right? But I'm not going to make all my fractions have the LCD. Instead, I'm going to multiply each one of my fractions by h plus 4. Okay, if you want, you can put that over 1. Excuse me. Okay, if you want, you can put that over 1, like that, and like that. And then when you multiply here, the h plus 4 and the h plus 4 will cancel, leaving just an h. Here you'll have a negative 3 distributed, negative 3h minus 12. Make sure you get a minus 12 there. And here the h plus 4 and the h plus 4 will cancel, leaving me just a 2. Well, now I can combine my like terms right here and get a negative 2h minus 12, and that'll equal 2. And then I can add 12 to both sides. And I'll get negative 2h negative 2h equals 14, dividing by negative 2 will tell me that h equals negative 7. And I'll check my restriction. I know my only restriction on h is that it cannot be negative 4, so this answer is good. Now, just by the way, if I plug this in to the original equation, what was the original equation? It was h over h plus 4, right? And that was minus 3, and that's supposed to equal the same as 2 over h plus 4. Well, let's test it out and see if it works. Let's plug it in. So I'm going to put negative 7 in, so I'm going to have negative 7 over negative 3 minus 3, and that's supposed to equal 2 over negative 3. Okay, well, there's a couple different ways to do this. I guess if I wanted to, I could get a common denominator here. First of all, this negative 7 over negative 3 is going to simplify to 7/3. And then negative 3 is the same as negative 9/3. I just got the common denominator there. Well, 7 minus 9 is negative 2 over 3. Well, that's the same as 2 over negative 3, right? It doesn't matter if that negative's in the numerator, denominator, or in front of the fraction. Remember, this is the same as this, and that's the same as that. All three of them are equal, so it works. All right, good deal. So let's take a look at graphing. I don't think we talked about graphing here on our review videos yet. First thing I'm going to do is I'm going to find my restrictions. And I know that x cannot equal 5. So I'm going to have a vertical asymptote wherever x is 5. 1, 2, 3, 4, 5. Just like that, right? Okay, and I know furthermore that my horizontal asymptote, y is not going to be able to equal 1. And I got the 1 right from there, right? Okay, so I'll put a horizontal asymptote at 1. Looks like that's off a little bit. I'll see if I can move it up. And that's pretty good. All right, so now I'm going to plug in a t-table. And I'm going to see what happens. I'm going to start with my positives. I'm going to start with a number, say like 10. I'll put 10 in. And I'm going to get 2 over 10 minus 5. So 2/5 plus 1 is 1 2/5. So the 1 2/5 is going to be the y-coordinate. So that's going to be a little bit less than 1.5 right there. Now I'll put 6 in, because it's 1 unit away. So I'm going to get 2 over 1 plus 1 is 3. So at 6 I get 1, 2, 3 right there. And now I'm going to put a number really close to 5 in. I'll say 5 and 1/10. All right, so if I do 2 over 5 and 1/10 minus 5, that'd be 2 over 1/10. 2 divided by 1/10 is 20. Plus 1 is 21. So that's going to shoot way up here. So I know, oops, I must not be in draw mode. That's going to shoot way up here. So I know this part of the curve is going to do something like that. Okay. Now, by the way, what did I get? 3 there and then 21. Now, I'm going to use symmetry and pick out my other values. Now, you shouldn't be erasing anything. I'm going to erase just so I can keep everything in the same spot, but you should just do yours on, another part of the page. And I'm going to pick 3 more x's, but I'm going to use symmetry. So the first point I put was 10, 5 units away from the asymptote. I'm going to go 5 units the other way, and I'm going to pick 0. 2 over 0 minus 5 would be negative 2/5. Negative 2/5 plus 1 would be 3/5. So at 0, I'm going to get 3/5. So just over halfway. And remember, over there was just under halfway, right? Okay, so I get 3/5. All right, then I went 1 unit away at 6, so I'll go 1 unit away on the other side, which would be 4. 2 over 4 minus 5 would be 2 over negative 1, negative 2. Negative 2 plus 1 is negative 1. So at 4, I'm at negative 1. Okay. Now I'm going to go to 4 and 9/10. because it's 1/10 away on the negative side of 5, or the smaller side. So, let me see here. Oh, by the way, notice that this point right here is 2 units above the asymptote. And the symmetrical point here is 2 units below the asymptote. It's 1 unit away, 1 unit away. Okay, that's why I'm picking these points on purpose. All right, if I put if I put 4 9/10 in, the denominator is going to become negative 1/10. 2 over negative 1/10 is going to become negative 20. Negative 20 plus 1 is going to be negative 19. So that is going to be something like way down here. And then I can see my curve is going to do something like this. And remember, it's not possible to draw it perfect. But there you go. All right, never crossing the asymptotes. If I should give you one like this on Thursday, this would be a pretty advanced problem, number 4 here I'm looking at. The first thing you want to do, factor that denominator. X plus 4 and x minus 4, right? And so I'm going to have 2 restrictions on x. X cannot equal 4 or negative 4. So I'm going to put in at 4, and then I'm going to put 1, 2, 3, 4, like that. Okay. Now I know my restriction on y is that y cannot be negative 2. Ooh, I'm not in the drawing mode. Y cannot equal. See, that's my other asymptote. I got it from right there. All right, so negative 2. Okay. So now I'm ready to go for my t-table. Remember, I'm going to get a 3-part graph. It's going to do something like this. Okay, so I'll start. I'm going to have to use more values for the t-table. And let's see here. Let's see, let's put in 10 again. All right, and if I put 10 in, and I can use x squared minus 16. So it'd be 100 minus 16, which would be 84. 1 over 84, negative 2. So I got 1 over 84 minus 2. So that's going to be a tiny number. I mean, that's going to be negative 1 and 83/84, right? So almost negative 2. So I'm going to be down here. Okay. So I got what? Negative 1 and 83/84. Pretty darn close to negative 2. Closer than I drew it, to be honest with you. All right, now I'm going to put 5 in because it's 1 unit away. I'm going to get 25 minus 16, which is 9. So I get 1/9. 1/9 minus 2. If I take 1/9 away from 2, I'm going to have 1 8/9 left. So that's still pretty close. All right. Now I'm going to pick a number like, say, 4 1/10. Now 4 1/10 is a kind of a pain to square, but you know, it's okay to use a calculator. And so I'm going to do 1 divided by, I'm using a calculator, the quantity of 4.1 squared minus 16, and I get 1.2345679, which is kind of cool, minus 2, and I get a negative 0.7654320. So I get a number that's a little bit less than negative 1. Okay, so something like that. If I plug in another number, let me show you what I'm doing here. Get off the graph mode. Oops, I can quit. And I'll clear that. All right, so I'm going to do 1 divided by 4.001 squared minus 16. Get that answer, and then I'll take 2 away from it. And you look, I'm getting some really large numbers. So I can say with a lot of confidence that this graph is going to come down here like this and then shoot way up high. Okay, now I'm going to go for the symmetry first. I'll do my symmetry in red. I'm not going to go, I went 6 units away from this asymptote. I'm not going to go 6 units away this side. I'm going to go 6 units away here, which will be at negative 10. All right, so I'm going to get the same exact number because I'm going to square it, right? And when I square negative 10, I'm going to get 100. I'm going to get the same exact numbers out. So it's going to be negative 1 and 83/84. Okay, so at negative 10, I'm going to be smack down here. At negative 5, I'm going to end up like here. And just because of symmetry, I'm going to kind of cheat and go like this. I know it's going to do that because I know I'm going to get the same exact numbers out. All right, now I've got to get those the ones in the middle there, which it's going to do something like this, but I don't know exactly where, but I know I'm going to end up with something like that. So I'll do that portion in blue. And I know my equation is what? 1 over x squared minus 16. And that's minus 2, I believe, right? Okay, so it's y equals that. All right, so I'll tell you what. I'm going to plug 0 in because it looks like 0 is in the center. 0 is going to kind of be the vertex. So I'll get negative 1/16 minus 2, negative 2 and 1/16. All right, 0, so negative 2 and 1/16 is going to be pretty darn close to that vertex. All right, now I'm going to plug 3 in, and I'm going to get 1 over 9 minus 16, which should be negative 1/7. Negative 2 and 1/7, right? Am I doing that right? Yeah, I sure am. So that's really not moving very much. Now if I put negative 3 in, excuse me, I'm going to get the same thing. Because when I square that negative 3, it's going to become 9. 9 minus 16 is going to be negative 7. And so I'm going to end up like this. All right. Now, let me pick 2 more values for my t-table. And I'll use my calculator to help me do these. I'm going to pick 2 numbers very close to my asymptotes. Okay, so I need to finish this problem up. Sorry, I had to stop for the algebra party. So now I've picked those 3 blue points, and I'll tell you what, I'm just going to use my calculator here, and I'm going to pick some points really close to those vertical asymptotes. And I think they're at, what, 4 and negative 4? So I'm going to pick a number just smaller than 4, and I'm going to go ridiculously close to it, like that, and I'm going to use my calculator to help me. And then I'm going to pick one just larger than negative 4, negative 3.999. And I'm just looking for something to happen, and if it happens, I'm good. All right, so there's my equation. So I'm going to come over to my graphing calculator, and we'll clear that out. And I'm going to go 1 divided by, and I'm going to do 3.999, and I'm going to square it. And then I'm going to subtract 16, I believe, right? And then I can't remember. I think I'm supposed to, is it add 2? Subtract 2. Okay, so then I'll subtract 2 from it, and I get this really large negative, negative 127 and a little bit of change there. So when I get really, really close here, I'm going to shoot way down here. Okay, now watch what's I'm going to do the same thing with the negative, and second enter, and second enter again, and I'm going to come over here. I'm going to add another set of parentheses. Second insert, parenthesis, and I need negative 3.999. And then I need to close those parentheses. Because remember, whenever you substitute in a negative, you should use parentheses because that exponent is going to apply to that negative. If you don't, you're going to get a different answer. So that's how I did that. So I'll get that answer, and then I'll subtract 2. And notice I get the same exact value. And I was expecting that to happen. Okay, I'm going to move my t-table out of the way here, and my values. And so I'm going to end up over here and getting that really tiny number. And I'm going to get this kind of parabolic thing going on here. It's not quite the same as a parabola, but very similar. And it's going to do something like that. Of course, that's not going to be horizontal, but it's really hard for me, that difference, to show. Now remember the Cool Math, was it, website? I keep getting the name wrong. the cool math, yeah, with the free online graphing calculator. So go ahead and check that out. All right, Mr. Lawrence signing off. Sorry, I've got YouTube up. I'm getting ready to post this. Don't mind me. I will say good night, everybody.